Astronomers have found a rocky world 23 times more massive than our planet, challenging everything we know about planetary formation. For decades, planetary scientists operated under a strict rule. If a planet was too massive, it had to be a gas giant. You simply couldn't pack that much rock and metal together without gravity pulling in a thick envelope of hydrogen and helium. But today, that rule is breaking. Astronomers have confirmed the existence of a giant, rocky mega Earth that weighs in at 23 times the mass of our homeworld. This discovery is not just a new entry in a catalog, it is a direct challenge to the fundamental physics of how planets grow. We are looking at a world that should not exist, according to the standard textbooks, and that makes it one of the most exciting targets for study in modern astrophysics. This mega-Earth was detected orbiting a nearby star, a place where the conditions are far more extreme than anything we experience on Earth. The host star is active and bright, bathing the planet in intense radiation. Yet, despite this hostile environment, the planet has retained its solid, rocky identity. It stands alone in its system as the most massive rocky world, with other smaller companions drifting further out. This isolation makes it a perfect laboratory for testing theories of planetary formation. We are seeing a world that formed in a way we did not expect, proving that nature is more creative than our mathematical models. Here is the core problem that makes this discovery so strange. When a planetary core grows beyond a certain threshold, usually around 10 times the mass of Earth, its gravity becomes strong enough to capture vast amounts of gas from the surrounding nebula. Once that gas starts pouring in, the planet rapidly swells into a Neptune, or Jupiter. But this Earth avoided that fate. It somehow stopped growing as a rock before it could become a gas giant. This suggests that the process of gas accretion is not as automatic as we thought, or that this particular planet formed in a region of the disk where gas was scarce or depleted. Let us talk about what it would be like to stand on this world. With 23 times the mass of Earth, the surface gravity would be crushing. Even if the planet is larger in radius, the sheer weight of the material would create a gravitational pull that is difficult to comprehend. This intense gravity would hold onto any atmosphere with a vice-like grip. Volcanic gases, water vapor, and light elements would struggle to escape. The planet would likely be shrouded in a dense, high-pressure blanket of air, creating a surface environment that is nothing like the blue marble we know. One of the hottest topics in the scientific community right now is whether this planet actually has an atmosphere at all. Some models suggest that it lacks a primary hydrogen or helium envelope, meaning it did not capture gas directly from the star's birth cloud. However, others argue that it must have a secondary atmosphere, forged by volcanic outgassing and retained by its immense gravity. The debate is ongoing, but the consensus is leaning toward a world that is geologically active, constantly reshaping its surface and feeding its own sky with new gases. Over on the space subreddit, the community dove into the implications of this discovery. One commenter pointed out that the surface gravity might make space travel impossible for any inhabitants using chemical rockets. The consensus there was that while traditional rocketry might fail, other methods could still work. Another user noted that this planet is more like a super-Mercury than a super-Earth, given its proximity to its star. There was also a sharp reminder about detection bias. Massive planets are easier to spot, so we might be seeing a skewed view of the universe, where Earth is actually the outlier, not the rule. This mega-Earth is more than just a record breaker. It is a signal that our understanding of planetary diversity is incomplete. We need new models to explain how a rock can grow so large without becoming a gas giant. It suggests that the boundaries between rocky planets and gas giants are blurrier than we thought. As we continue to scan the skies, we will likely find more of these strange heavy worlds. They will force us to rethink the history of our own solar system and the potential for life in the cosmos. Thank you for joining us on this deep dive into the cosmos. If you found this exploration of the mega-Earth fascinating, please subscribe to OrbitReports for more precise, calm, and wondrous breakdowns of the universe. We will see you in the next mission. Thank you for joining us on this deep dive into the cosmos. If you found this exploration of the mega-Earth fascinating, please subscribe to OrbitReports for more precise, calm, and wondrous breakdowns of the universe. We will see you in the next mission.